Hey, what's going on, everybody? My name's Rian Sarka. I'm a junior at Portland State University, and today I'm going to be showing you a at-home physics experiment. The main topic today is electrostatics, or more commonly known as static electricity. Static electricity is defined as a stationary electric charge on an object, typically produced by a loss or gain of electrons through friction with another surface. You may have noticed this effect when you hold a balloon near your head and your hair stands up, or when you get shocked by a metal slide at the playground. Charged objects generate electric fields that repel like charges and attract opposite charges. In the balloon example, your hair and the surface of the balloon are oppositely charged and therefore attracted to one another. In this experiment, we will be examining a similar attraction, but with water rather than hair. Now all you need to do this experiment is a roll of Scotch tape, a pen, and a water faucet. That's it. Start by tearing off 4 pieces of tape that are all about the same length. On 2 of the pieces, fold only one end of the strip to make a tab to hold. These will be your control strips. On the other 2, fold both ends to make 2 tabs. These will be the test strips. Folding both ends will make it easier to observe the effect the strips have on the water stream. Place one from each pair of strips on a countertop near the faucet and mark the tab with a pen. These will be the positive strips. Make sure to press these down firmly. Place the other 2 strips directly on top of these, press again, and mark these as well. These will be your negative strips. Now when you're doing this, make sure that the control strips are on top of one another and the test strips are on top of each other. This will make setting up the experiment much easier. Now tear up both control strips and hang them up somewhere. I found that my towel rack worked perfectly for this. Then tear up the top test strip and compare to the control strips to check the sign of the charge. Remember that like charges will repel and opposite charges will attract. After checking the sign of the charge, turn the faucet on at a low pressure and slowly bring the test strip closer to the stream with the sticky side facing the water, and observe the effect that it has. Repeat this with the bottom test strip and you're all done. Here I am turning on my faucet, making sure that it's at a low enough pressure so that the charge can affect it. Now I will rip up my top test strip, which is labeled negative. Now I'm making sure to do this at a smooth, consistent speed. Now I'll approach my control strips with my test strip, and notice that as we approach the negative control strip, that they are repelled. Now, when we bring it over to the positive strip, we see that they are attracted. Next, I'll take my test strip, holding both ends with one hand, and slowly approach the water stream and observe what happens. Now we can see as the strip gets closer to the water that it sort of bends the stream towards it. Now I will take my positive test strip, rip it up from the counter, take it over to my control strips. Notice that when we approach the positive control strip, that they are repelled. And when we approach the negative strip, they are attracted. Now I'll do the same thing with this test strip, slowly approaching the water, and we can see that the same effect occurs. So why does this happen? If we know that like charges attract and opposite repel, then shouldn't one of the test strips be repelling the water stream? Well, not necessarily. You see, water is actually a polar molecule, meaning that one end is slightly negatively charged and the other end is slightly positive. This is due to the fact that oxygen has more protons than hydrogen, and the electrons in the molecule are more attracted to that end, making it negative. Due to the water's polarity, when the charged strip of tape approaches the stream of water, the end of the molecule that is opposite the charge of the tape is pulled towards it. This means that no matter the sign of the outside charge, it will still attract the water stream towards it. That wraps up my experiment, guys. Thanks for watching. Don't forget to smash that like button, hit the bell, and subscribe. Thank you.